Pi is the circumference of a circle divided by its diameter. It's approximately 3.14. It means that the circumference of a circle is about 3.14 times its diameter. Since only circles have diameters, pi is a value that applies only to circles. But if we reinterpret pi, we can extend the concept of pi to polygons. Every polygon has a perimeter, so we can replace the circumference with the perimeter. However, polygons don't have diameters. To apply the idea of pi to polygons, we need to reinterpret the diameter. In a circle, the diameter is the longest line segment connecting two points on the circle. So, what would correspond to the diameter of a circle in a polygon? Let's take a square as an example. What's the longest line segment connecting two points on a square? It's the diagonal. So, this diagonal corresponds to the circle's diameter. Now, let's find the pi value of a square. The length of the diagonal is 1. We need to find the side length x. In this triangle, the angle is 90 degrees, and the two sides are equal. This is an isosceles right triangle. These angles are 45 degrees each. We find sine 45 degrees. This equals 1 over root 2, so x is 1 over root 2. Since the square has 4 sides, we multiply this by 4. That gives us the perimeter and the pi of the square. 2 root 2, approximately 2.828. Next, let's find the pi value of a regular hexagon. The longest line segment here is this diagonal. The length of this diagonal is 1. This side length is 1/2. A regular hexagon can be divided into 6 equilateral triangles, so each side is also 1/2. Since there are 6 sides, we multiply 1/2 by 6. The perimeter is 3. Therefore, the pi value of the regular hexagon is 3. Finally, let's find the pi value of a regular pentagon. This diagonal has a length of 1. We need to find the side length. The regular pentagon is inscribed in a circle, and these arcs are all equal. Since these angles correspond to the equal arcs, they are also equal. Meanwhile, this angle is an exterior angle of this triangle. In a triangle, an exterior angle equals the sum of the two non-adjacent interior angles. That gives us the size of this exterior angle. These two angles are equal. Since this is an isosceles triangle, this side is also x. This diagonal is 1, so these two sides are 1 minus x. These two triangles are similar, so their corresponding sides have the same ratio. Expand this proportion. It's a quadratic equation. Solving it gives us the value of x. Since x must be positive, this is the value of x. Multiply this by 5, the number of sides. It gives us the perimeter, so this is the pi of the regular pentagon, approximately 3.09. Now, compare a few pi values. The circle has the largest pi value. The square has the smallest. I wonder what the pi values of other regular polygons would be.